Is that screen shared to you?
Yes.
Okay. So when we talk about sound, actually sound is a form of longitudinal wave. Before that, we have completed the transverse wave. So it is longitudinal wave. Okay. So when we talk about longitudinal waves, you believe that they travel in the form of compressions and rarefactions. So sound is a wave which is produced due to vibration of the source. When a sound wave comes into the contact with the solid, those vibrations can be transferred to the solid. Did we do this sound waves or not? ऐसे मुझे याद क्यों आ रहा है कि
No, we didn't.
sorry.
Like we did like a part of waves, but not like a separate topic.
Okay, separate nahi kiya na. Yes, that's fine. Okay, so sound waves are produced due to vibration of the particles where we are going to generate the vibration. For example, sound waves uh, can cause a drinking glass to vibrate. Anything you can ask about that. You can give an example because in SEMA exam they set this example. So we can produce sound waves in different mechanisms, and we believe that these sound waves are having so much energy that they can shatter a glass even. So that is basically what does it this these two sentences mean. Okay, so they are longitudinal. So longitudinal mean their direction of vibration of particle is parallel to the direction of propagation of energy. Yes, Ariba, do you believe that they are longitudinal?
Yes, sir.
Okay, so Hassan, longitudinal are those in which vibration of particles and direction of energy is parallel. So sound wave are longitudinal because molecules vibrate in the same direction as that of the energy transfer. So please remember this thing. So when we talk about the sound, sound have the uh, sound required a medium to travel through. Okay, so sound needs a medium to travel through. That's why it it is a mechanical wave, so it cannot travel through vacuum. Remember this thing, that it cannot travel through vacuum. So we say that sound cannot travel through vacuum. So the range of the frequencies is, this is very important. I used to use this one in my notes. 20 hertz to 20,000 hertz. It is called your audible frequency range. What do we call it? Audible frequency range. Okay, is it clear? It is audible frequency range. So
Yes.
that travels in the form of compressions and rarefactions. You are asked what are compressions and what are rarefactions. So compressions are those portions of the medium or regions of the medium with higher density, right? Where places where the particles are or molecules are closer together. And rarefactions are actually those portions or those regions of the medium where particles are apart from each other. They have lower density. Okay, is it clear to all of you?
Yes.
Okay, then we have this demonstration of sound, that when we demonstrate the sound, if I have a tuning fork, this is called your tuning fork, and that tuning fork is actually vibrated in front of a tube which is filled with air particles, or which is filled with particles, or any small particles which can vibrate with that much energy. That is your tuning fork. So hoga kya कि that energy is produced by tuning fork, and that is propagated in this direction. So those particles are coming closer to each other at some portions or at some regions, and at some regions they are getting apart from each other. So I can clearly talk about that. That these are the compressed portion. Here the density of the molecules is greater, and these are the portions where density is less. So here it is mentioned that these are the compressions. This is compression. This is compression, and these these portions, they are rare fractions actually. Got it? So sound is a longitudinal wave and that travels in the form of compression and rarefactions. So we discussed this all over here. So remember this thing, when we talk about the wavefronts are actually representing the compressions and rarefactions. The portion where the lines of wavefronts are closer, these are the compressions, and the portions are the region where lines are apart from each other. I mean the maximum gap or maximum distance between the lines, those are showing your rarefaction. Okay, low pressure area. So this was basically the compression and rarefaction portion. Then investigating the sound, does that travel in vacuum or not? So here sound wave travels in vacuum. So we sorry, I take my words back. Sound do not, our sound waves do not travel in the vacuum, right? So for that purpose, what do? We have a bell jar experiment. In that bell jar experiment, ringing the bell can be heard. This is that a ringing bell is being used. It is not being evacuated, so it is placed in a jar, and jar is open to air, so you can see the ring bell ringing and you can hear the sound as well, right? Now you have evacuated the air. When you have evacuated the air to somehow, you have less sound heard, right? By air removed from the bell jar by a vacuum pump. Air is fully removed, then what will happen? You will just see that it is vibrating, but you cannot hear it. It means when a sound is being produced, here sound is being produced in all these three steps, three diagrams, but you cannot hear that in the last one. So this shows that sound cannot propagate through vacuum. I mean, it needs a medium to propagate. Okay, so after that we have the characteristics of sound, properties of sound wave. So when we talk about characteristics of sound wave, actually we mean that there are some properties by which we can differentiate the sound from one another. So main properties of the sound are pitch and loudness, which are actually in the syllabus. There was a timbre as well, but that has been excluded now. Okay, अब आप देखो, when we talk about pitch means frequency. If we have the higher pitch of the sound, it means the sound is of high frequency, and low pitch sound, it means low frequency sound. So pitch actually ये होता है कि pitch is shrillness of the sound or graveness of the sound. So for example, now at this stage what I am talking, that is low pitch sound. But when I will say speak in this way, it is what? High pitch sound. Are you getting it?
Yes.
So high pitched mean high frequency. Shrill sound. Shrill sound mean this one. Or the sound of, you know, cry. क्या कहते हैं चीख को इंग्लिश में क्या कहते हैं हसन? Scream. हाँ भाई अरीबा.
Yes, sir. It's to scream.
Screaming, yes. So that sound is a shrill sound. And heavy sound is basically called grave sound. भारी, जैसे बहुत मतलब thick sound कह सकते हो आप, right? So let's talk about the graphical analysis of that. Yeah, this is the pitch of that. Then loudness means if the amplitude of the sound is high, then it is louder, and if the amplitude of the sound is low, it is less louder. Actually, this is the volume of the sound. This is actually the volume, and this is your bass and treble. BASS or BASC? I don't know about the spelling, but I know about the volume in my tape recorder, right? So there are some graphs. You people are asked in this way. You people are not asked in that way verbally. You will have a graph here. If its amplitude is lower, it is less louder sound. low volume sound. And if it has larger amplitude, it is high volume or louder sound. In the same way, if there is a low frequency, like zzz, it's a low, so it has low frequency, so very large wavelength is being produced. But if you have whistling, that is high frequency, so high pitch sound. So low pitched have low frequency, high pitched have high frequency. So I believe that this would be clear to you. So amplitude of the wave determines the volume of the sound, and frequency determines the pitch of the sound. Clear hai? Okay, this is
Yeah,
basically
clear.
good. Now this is a description of a sound wave. Different sound sources have different wave shape. This is called your pitch of the sound. Oh, sorry, timbre of the sound. What do we call it? Timbre. Timbre of sound. Timbre of sound tells us, for example, when we uh, ask, or when we ring the bell at the gate, someone asks me who is there. We rarely tell about ourselves. We don't tell the name actually. We say मैं हूँ, yeah, I am at the gate, right? So when we say that, our sound is being recognized, not our name. So that is the quality of the sound, right? Timbre means quality of the sound. So when you people will hear me in any anywhere, although you did not see me, but you will say, oh, sir idhar bhi physics padha raha hai yaar. So quality of sound, is it? So that is how we identify the source. That is quality. So here we have two different sound sources, right? They have different specs. This is a CRO, oscilloscope. So oscilloscope have different behaviors. So unfortunately, I will not get in detail of that. But here the main concern is the shape of the wave. So they are having different shapes, different sound sources are being produced. The oscilloscope have the volt details, sorry, volt, sorry, have a lots of dials and buttons, but their main purpose is to display and measure the change in the signal like sound wave and the alternating current. Anyhow, when a microwave is connected to the CRO or oscilloscope, the longitudinal sound wave are displayed as thought the waves are transferred. I mean, they are shown in crest and troughs. Basically, that mic shows the electrical signal. The time base or x-axis is used to measure the time period. Right here is the time base. I can show you that time base in that. Yes, this is the time base. This one. Okay, this is your time base, and this is your y gain, although that is not included in your syllabus as calculation, but I have to show you that because CRO is emerging tool in our daily life. ठीक है, तो ये बात याद रखनी. A sound wave depicted as a transverse wave in oscilloscope, so it's not a big deal, you can do that. This is that trace of sound. What do we have? We have the traces of sound. Traces of sound. ठीक है जी. तो ट्रेसेस के ऊपर हमारी बात होगी. Now this trace tells us some important information. This is amplitude, this is its time period, right? Because time is given to us, time base of that wave is time, so that is given to us. So that is, we can predict frequency also. ठीक है, frequency mean if we get time period we can get frequency. So if the waves are closer to each other, oh, if the waves are closer to each other, for example, I can draw a wave by myself. If it would be, I will try to draw. Okay, what about this wave? Is its loudness less or more than the blue one?
Less.
Less. Hassan, are you agreed to? Hassan, is the loudness of red wave is greater than blue or less? Ariba, what about the
Yes, sir.
frequency of this green wave and red wave? Oh, sorry, pitch of that. You have a green trace on the CRO as well. And do you believe that this trace has higher frequency?
Yes, it has higher frequency.
So that green wave would have higher pitch or not?
It would.
Yes. And what about its amplitude as compared to that of the blue one?
The amplitude is lower than the blue one.
Okay. And pitch is higher. Okay. Is it clear to all of you?
Yes, sir.
Okay, good. So here we are talking about reflection of the sound. Reflection of the sound produces an echo. And when we talk about echo, echo is having different uses. For example, in our empty rooms, we use to whistle in the presence of echo. If there would be no echo, we will not do that. We used to sing in empty areas. Usually, you know, some people are said washroom singers like me because there is echo, right? So echo makes your sound impact something different, right? So echo is a game of reflection. तो आपने ये देखना है कि the actual uses of echo are when we want to measure the depth of the sea, we send a ultrasound pulse down the sea. Oh yes, this is the emitted ultrasound pulse, and that ultrasound pulse is reflected back, and then it is basically reflected back from the sea deck, and then it is received by the ship, and then we calculate the depth of the sea. So that is the game. Okay, here I would love to explain this to you. Check karo, this is your depth, right? What is this? This is the depth. So let's say this is your D. So how to calculate this D? So this, the sound will take some time T1 to go back. Let me explain it over here. Sound will take some time T1 to go back, and the same time would be taken by the sound to come back, T2. So what is the total time to uh, what is the total time in which the sound is coming back? That is your T1 plus T2. So I can say that in the time between sent and received, sent and received, 2 times d, 2d distance is traveled by the wave. How much distance is traveled? 2d distance is traveled by wave. So when it is 2d distance, can I say that by using the equation s is equal to vt, that distance is 2d, speed is v, and time is t. So you can calculate the depth of the sea as vt by 2. Remember this thing. This is a very useful equation in reflection of sound. Very, very useful, right? Where there is a word of reflection or echo, don't miss this equation. Multiply speed and time twice. Sorry, multiply speed and time and divide it by 2. So you will get distance traveled. Okay. Then we have the method of investigating the reflection of sound wave. So if we have clap, 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 then we will have the echo of that. So that is just a 50-meter distance. So you will hear the sound. So the minimum distance should be 50-meter or more. Okay. So oh, yes, he has given that formula over here. So, speed of the sound is calculated by the distance traveled by the sound to go to the wall is d, and coming back to the wall is also d. So, total distance is traveled as 2 times the distance to the wall divided by time taken. So, speed is calculated by 2d by v, 2d by t, or distance is equals to Vt by 2. That is the same game actually. I have just made D a subject and he made V as subject. So that would be used for the calculation. So next is measuring the speed of the sound. So speed measurement के लिए we have two, three methods. One method is the sound between 2 points. Measure the speed of the sound by using a loud noise. Just prepare a, or just make a clap, uh, and keep the observer 100 meter away from the sound source, and this observer will see the sound, sorry, she will see when the sound is being made, mean the clap of these two objects are these logs, wooden logs, and then she will start the stopwatch, and then she will wait when the sound would be reaching to her. When she will hear it, she will stop the stopwatch. So actually the time is noted down. This is your time t is equals to 0 at clap, and this is your time t is equals to t at bang. When she hears the bang of sound, she stops the stopwatch. So this is the time taken by the sound to reach this, to travel this distance. So we use that and just use that equation because there is no echo taking place. So you will use that v is equals to distance divided by time taken. That's a simple equation used over here, right? That, yeah, this he has mentioned this over here because no reflection is taking place. Then we have this technology. We use two different mics, and they are 5 meter apart, I mean few meters apart from each other, and we use the CRO to get this trace, and then by this the speed of the sound is distance between two microphones and divided by time between the peaks. Here is the CRO, these are the peaks. So for example, this is time, as I have shown you the CRO on at the top. So this is the time between CRO. So you measure these two and then use that equation. And then when you are going to measure the speed of waves in the water, that we use a hydrophone. And hydrophone means that is a device which is being to detect the sound in the water, just like your stethoscope. It is a hydrophone. Okay, the same thing is being done, same formulation is being done, but for the calculation of speed, distance moved by the time taken, right? And important thing is the speed of the sound alters. Speed of the sound in air is 330 to 350 meter per second, but speed of the sound in liquid is almost 1500 meter per second, and speed of the solid is almost 5000 meters per second. So speed of the sound is slowest in the gas and fastest in the solids. So this was the fact you have to now. Then we have to talk about ultrasound. Ultrasound is, as I told you, that the frequency of sound between 20 hertz to 20,000 hertz is called your audible frequency range. Okay, it is your audible frequency range. But the frequency lower than this, it is called infrared, and frequency above that, it is called your ultras. Oh no, no. Before that, I was actually at spectrum, so I called it infrared. No, it is infrasound. And this is your ultrasound, not ultraviolet. So there is a question, trapped question, that which speeds or which of the following have the highest speed difference or maximum speed difference. So ultraviolet, ultrasound, and sound. So let me call it A, B, and C. So which two pairs are having highest speed difference? A and B, and A and C. And speed of B is equals to speed of C. Got it? Then there are uses of ultrasound. Ultrasound is basically used in different mechanisms. When ultrasound reaches to the boundary, This is a question I remember that it is asked for 3 to 4 marks. That how the ultrasound is being used. So you have to remember that the ultrasound is emitted from the ultrasound source. It reflected back from the body. Ultrasound reaches to the boundary between two mediums, right? And then these they're partially reflected. Okay, when it is partially reflected, then those reflected pulses are received, and the time delay between received and sent pulse is measured, right? And then we can now, are we now the speed of sound in ultrasound, sorry, we now the speed of ultrasound in the medium, and then we can check the distance or thickness of that medium. It is V times T divided by 2. Right? So this is basically the ultrasound in medical. We use a lot, there are so many use of ultrasound in the medicine, right? We use to detect the ultrasound for inner organs, to get the dimensions of that, to get the diagnosis of some abnormalities in the body, to detect some kidney stones and all that stuff. There are so many uses of ultrasound with our in our medical field. Then we use to check the ultrasound whether there are some cracks in the metals or not, right? So that's it. I believe that this is what this is all about, the ultrasound. So today I was at the fire so that I covered two chapters in your one lesson. So I believe that they did not make a mess to you, but I hope that the things would be settled down.
What?
Okay, so we will
Yeah.
practice some